So this is the question for October number 2025. Last question, 15 marks for the pseudocode. First, let's read this question. Program is required to test the fairness of a random number generator. The 1D array random number is used to store 100,000 random integers. Now you have to stop here, underline this sentence, and you have to go to your blank page in the question paper and you have to create a draft. You have to create an image of an array with 100,000 random integers, okay? A 1D array. Before you draw this, read the second one as well. The 2D array counted number is used to store integers 1 to 10. So it means that the 100,000 random integers that we are going to store, the range is from 1 to 10 inclusive, which means 1 is also included and 10 is also included. And in the second column of your 2D array, you have to store the frequency of each integer that now, for example, if the random number 1 was generated 250 times, so it's going to store 1 in the first column and then 250 in the second column. All right. So first, let's visualize what does this even mean. So here I created the first array, which was the 1D array random number with 100,000 elements in it, starting from first index up till 100,000. And in this random numbers are stored 3, 7, 10, 4, 6, and then so on. The column stores the random numbers generated like 1, 2, 3, 4 up till 10. And this is the frequency, how many times the random number was generated. 1, like 12 times, 8 times, 6 times. It's just an example. Now, once we know that what these arrays require us to do, now we have to move on to the second part of the question, the requirements. Okay. First, you have to read this. After this, I'm going to tell you a method. After that, you are going to solve the actual questions. So, the first requirement is that you have to generate 100,000 random integers between 1 and 10. Okay. Store each integer in appropriate array. We're going to look onto this. Calculate the frequency of each of integers 1 to 10 and store these values in the appropriate array. Now, for the first time, if you're going to read this question, it's going to seem very hard to you that how are you going to even do this? But we are going to make it easy by first breaking everything down. I'm going to tell you a method, so don't worry. First, just read the requirements. Sort the contents of counted number array in descending order. Just underline the keywords. What you have to do, you have to calculate the frequency. You have to arrange it in descending order. The number should be between 1 and 10. Calculate the chance of generating each of integers 1 to 10. And the formula for chance is already given to you. And at the last, you have to output it. You have to just find the keywords. Now, the next approach is that you have to draw 4 boxes like this. And you have to label them. The first one is I, which means input. The second one is V, which means variables. The third one is C, which means conditions. And the fourth one is AND, E. Okay. So you have to remember this by IVCE. First, you have to fill in these boxes, then you have to jump into the questions. You have to draw your arrays, you have to fill these boxes, then you have to go towards the question. Okay, so first let's identify what inputs do we need for this question. So the very first thing is that we need to generate random integers, right? So just write random integer. Now immediately there will be something clicking in your mind that how do we generate a random integer using pseudocode? We have learned the pattern for it, like there's a specific function that we use to generate a random integer. We will give them the range from 1 to 10. So you can write a side note here for yourself that you have to generate the random integer using the random function. Then you have to also keep in mind that there should be 100,000 random integers. Now, there'll be something else clicking in your mind that you have to loop it from 1 to 100,000 to generate random integers. You can't do the same thing all over again for 100,000 times, right? So this is basically the input that we need. After this, what are the variables? What are the data structures in which you are going to store the values? The first two was the arrays, the random number and the counted number. Now you have to keep this in mind that you have to declare these arrays as well. Random number and counted number. You are given the size of it and what you have to store in the first column, the second column, okay? These are variables. Basically, the counted number, we have to update the frequency each time the loop runs as a random number is generated. Now, one more thing. Here in the question, it is specified that you have to use bubble sort to to sort the array in descending order. Now you always know that in bubble sort we use temporary variables. So you have to keep in mind that you have to create temporary variables for the bubble sort. Temp. I'm just going to write temporary variables so you don't forget for bubble sort. I don't have space here. And one more thing, in the bubble sort, you have to always use a Boolean value swap, in which you check whether two elements are swapped or not. If you don't know what is bubble sort, I'm going to teach you later on in this video. So for now, oh yeah, we also have another variable known as the index, which is going to keep a track of all the elements in a random integer as well as in a counted number array. So this is all the variables I could think of for now. So I'm going to just write it down, and then after I start thinking about the code, I'm going to look at these boxes and I would remember what I have to do. This third box is the condition box. You have to write each condition so that you don't forget that you have fulfilled all the requirements. So the first condition is that you have to sort it in descending order. Pardon my writing. And you have to keep in mind that you have to apply loops. A loop for random number generation and a loop for counting frequencies. For random number, you have to generate 100,000 numbers, so you have to loop from 1 to 100,000. And for the counted number, you have to loop from 1 to 10. To count the frequencies, that how many times, for example, 3 occurred, how many times 4 occurred. So that's why you just need 10 loops for it. You just have to count the frequency for each integer, 1 to 10. The end box specifies that what are we are going to output in the end of this program. So here it was written that we have to output each of the integers 1 to 10 in the order they are stored in the counted number array. So basically we have to just output to the screen the counted number array and the chance. So you have to just write that you have to calculate the chance first and output the array. Now before you start solving the question, you have to make an empty space, a few lines for declarations, because in our program we often make variables and then later on we have to declare it. So you have to do all the declarations at the last. But if you want to declare everything that you know first, you can declare it. For example, you want to declare the counted array, you want to declare the random number array because these are known to you, you know the size. So you can declare it, but please leave a few lines so that if you create a new variable in your code, you can declare it later on in the end of your question. And here we have the second 2D array, counted number with 10 rows and 2 columns. So the first cancel. So the first so before we start the question, I have declared the known variable. Here I have declared the integer random number, which has 1 to 100,000 values of integer, and this is 1D array. And for the 2D array counted number, there are 1 to 10 rows and 2 columns. This one specifies the rows and this one the columns, and it is also of integer. And I have also declared a variable swap for bubble sort. But we have to declare all the other variables first when we will create them in our program, and then we will come back to this. Okay, so the very first step is that we have to initialize our array counted number. Now you have to keep in mind that, for example, this is your array counted number. You have to store in it 10 random integers that you have to generate 1, 2, 3, and then so on till 10. Okay, and you have to store the frequency as well. How many times this number was generated? Like, for example, 300 times, 250 times. Okay, so this means that this is the array counted number. Now we have to store 10 integers in it. So that's why I have applied a loop from 1 to 10 for index 1 to 10. This is the index position. Counted number index 1. This one represents row and this one represents column. Index 1. This is the first index and this is the first column. In this you have to store the index value. The index value you have specified it here, like from 1 to 10. So it's going to first store 1, then 2, then 3 as the loop continues to run. And in the second column, index 2, this one is the row, first row, second column. You have to initialize everything to 0 first. Why? Because there's no frequency yet, because you haven't generated your random numbers yet. Okay, so that's why it will all be set to 0. So this counted number array, in the second column you have to set everything to 0, and in the first column you have to just store the index values from 1 to 10. Here is an example of counted number array which has 10 rows and 2 columns. The second column is set to 0 because there's no frequencies generated yet. We haven't calculated everything. And these are the index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first one is set to index values and the second one is everything is set to 0. Okay, so we have initialized our first array count numbers. The second array that we have to initialize is random number. We have to generate 100,000 numbers, so we have to take an array which should contain 100,000 storage locations. So the loop, we have to apply a loop because we can't do the same thing for 100,000 times again and again. I have to apply a for loop for index 1 to 100,000. Index means the location, like this is the first index, this is the second index, and this index variable is going to keep count of all the indexes 1 to 100,000. Okay, now I have to generate a random number in each of these place values in the first, second, third, and this will all go till 100,000. I have to generate random numbers in it. In order to generate a random number in the first position of array, first we have to take the array name, which is random number. This is the array name, random number. In the first index position, we have to store a random number. How do we generate a random number? So the trick is that you have to memorize the syntax for generating a random number in pseudocode. So first you have to write round. Round. Then you have to write the keyword random with two brackets, opening and closing. Now you have to multiply it with upper bound minus 1. What is the upper bound for the range of random numbers? The random number should be between 1 and 10 inclusive. So 10 is the upper bound, right? Like we have to generate 100,000 numbers in range of 1 to 10. So always remember that after this multiplication sign, I have to add upper bound minus 1. Upper bound was 10, 10 minus 1 is 9. And I have to plus the starting point, which is 1, 1 to 10. So the first value would be 9 and plus 1 is the starting value. This way, the computer will generate a random number for you and store it in the random number array in this index position. Now, for example, the random number that is generated is 3. This is going to be stored in the first index. Now, this loop is going to run and the value of 1 is going to change to 2. In the second position, for example, the random number generated is 6. And then this loop will keep running till 100,000 and it will keep generating random values 8, 6, 4, and a number can repeat again and again, and this way we can count the frequencies as well, that how many times the same number has appeared. This will all go till 100,000 loop values. Here I have written the pseudocode for index starting from first position till 100,000 position. In that array, you have to store the random number that is generated using this function. This is the upper limit, which was 9. This is the 0 is the decimal places that I want my answer to be. I want it to be in 0 decimal places. Then I will add the plus sign, and this is the first 1 is the starting value. I have 1 to 10 numbers, so 1 is my starting point. Okay, so now as your computer is going to generate a random number, you have to store the random number into a temporary variable known as the current number. And now you have to move to your second array, counted number, and then you have to access that index position using current number. For example, your computer generated 8 as a random number. Now you will store this 8 in the current number, and using this position, you have to move to the second array, which was the current number. Like for example, now we are going to the second array corresponding to that number. Now 8 was generated randomly, so now in the second array counted number, it will go to the 8th index position and it's going to update the frequency to +1. Now 8 has appeared, so it will, whatever the number will be here, it is going to just increment 1 in it, +1. Just like that, for example, 9 will be generated as a random number. Now using this 9, I'm going to store this 9 into current number, and using this current number, I'm going to access the second array, come to the 9th position and increment +1 in the frequency. This way I can count the number of times a particular number appeared. Now how would I look now? I want I want to access the second column of this array, right? So I'm going to write count number. How would I access the index number? The index number is stored in the current number, right? The current number in the second column. In this, I'm going to increment +1. Okay? So this is basically how I'm going to count everything. So here I've written the pseudocode as well. That first, whatever number you will generate, first you have to generate the number. Once you generate the number, you have to save it into this variable current number. Then using this variable current number that stores your random number, you have to access your second array, go to that particular index position. In the second column, you have to increment +1. This is the method for incrementing a number. You have to write the same thing, then assignment statement, then write the same thing again, then +1. Then when your second loop will run, then you will generate another number, then that number will be saved in the current number. Then using that current number index, you will go to that index with the counted number array. In the second column, you will increment +1, and like that. For example, the loop runs for like 100,000 times and 2 was generated maybe 500 times, and like this everything will be like stored, like for example, whenever 2 will be generated, 2 will be stored in the current number, and then we will access this array and then increment, this works like that. Now let's move. How would once we are uh, calculated, we are done with calculating all these values, like for example 800, and like for example anything. Now how are we going to arrange these in descending order, and how are we going to know that which number was generated the most and which number was generated the least number of times? Before we understand the pseudocode for bubble sort, I want to dry run this first. First, make you understand how would this work. Then we're going to look at the pseudocode of it. So here's our array, counted number, with 10 rows, 2 columns, the second one frequency count. And we have to sort this array based on descending order of the frequency count. Like the highest frequency count should come at the top and lowest at the bottom. Okay, and we have to swap the whole row, not only just the frequency counts. We have to swap the integer corresponding values as well. So here in this array, I have given you an example data just to make you understand. For example, the random number 1 was generated 150 times. The random number 2 was generated 680 times. The 3 was generated 210 times. 4 was generated 430 times. And then so on till 10. But for now, I want to sort this part of the array using the bubble sort algorithm. So let me first create a temporary storage here and name it as temp. This is known as our temp box. Okay, temp, temporary. This is the box. Okay, let me just make it with a darker color like this. Okay, so let's start from the very starting position of this array. So here in this array, let's start from the first index. On the first index, in the first column, I have 1, and in the second column, I have 150. And I have to sort this array in order of frequency count. So first, I'm going to check the first element and the second element. So I'm going to check 150. Is 150 greater than 680? Not obviously. So what we are going to do? We are going to swap this. We have to take 150 down there and 680 up there and their corresponding index values as well, the 1 and 2, okay? The random number that was generated. So first, I'm going to take this 150 and store it in my temporary variable and erase this from my array. And the same I'm going to, in fact, let me take just 2 boxes, one for the integer as well. So I'm going to name this as temp2, temp2. So here I stored 150 in there, and 150 corresponding index was 1, right? So random number 1 was generated 150 times. I stored them both and erased them from the array. Now this array position is empty. I want to swap this second one up there because it's greater. So 680 would go up there as well as the 2. Now, as you can see, these both moved upwards. So it means that the second position is empty now. Now we are going to store this value that we saved in our temporary variables back into the second position. So 1 will be here and 150 will be here. Our swapping is successful. Now, once we have swapped this, we are going to check the next array position. So once the swapping is done, we are going to assign true to the swap variable. Okay. Now let's do this with the second one. We have 150 and 210. Is 150 greater than 210? No, obviously no. So we are going to swap these both positions. But before we swap it, first we are going to store 1 and 150 in temporary variable. So we are going to erase it from here, and I'm going to store the value of the second column, which was 150 in temp. And in second temporary variable, I want to store 1. And now this array position is empty, so I'm going to move this upwards 2 and 3. And now this in this empty position, I'm going to keep my 1 and 150 back in place. Okay, now let's check for the next set of values, which is 150 and 430. Is 150 greater than 430? Obviously no, so we are going to swap it. First, we are going to store 1 and 150 in the temporary variable, 1 and 150. And then this position will be empty because it moved to the temporary variable. Now this place is empty, so we are going to make this move upward, and now this position will be empty, and we are going to take our temporary variables back into its place. Now you can see that my most significant, I mean the greatest value bubbled up to the first position. That's why it's known as the bubble sort. It takes the most greatest value and bubbles it up in the first place. However, this array is still not sorted. You can see that the greatest value is up there, but 210 is less than 430 and it's up there. Now we have to bubble the second most greatest value into the second position and then bubble the third most greatest value into the third position. So this loop will all over run again from the very start. It's going to compare again. Is 680 greater than 210? Yeah. So it won't swap it. Then it's going to check the next set of values, 210 and 430. Is 210 greater than 430? No. Then it's going to swap. We are going to do the same process. We are going to store in the temporary variables the values 3 and 210. This position will be empty and the adjacent value is going to move up, and this is going to be empty since it's moved up. We are going to take our values back from the temporary variables to 3 and 210. Now it's going to check again 210. Is it greater than 150? Yeah, we are good to go, so no swapping will happen. Now you can see that the second most greatest value bubbled up to the second place. Now this loop will keep running until the whole array is sorted. Okay, so this is how bubble sort works. But before we move to the code, let me just make something clear to you. We compared it like this, for example, um, initially, wait, let me just move everything back to its original values. So let's suppose we have the unsorted array again. Okay. So we always compared the first two values and then the second, third, fourth, like this, right? How would we do this in pseudocode? So you have to listen to me. We have to compare the frequency count values. Okay. So first we like compare, for example, 150 is 150 greater than 230. How would I access 150 and 230 in pseudocode form? So I'm going to call the array name, which is counted number index. Index is basically going to keep a track of wait, these values 1, 2, 3, and then it's going to increment it. Like when I'm going to apply a for loop, index, and then comma 2. It means that always remember that the array name comes first, then the row, and then the column position. This means which row and which column. So here, the index row, as the rows keep changing, right? We have to loop through all 10 elements. But the 2 will not change because I'm accessing the second column. I have to compare this with. Now listen carefully. I have to check whether it's greater than 230. And 230 is the next position. It means this is index plus 1. This one was index. Wait. So this was index. This was index. The 2 is index plus 1. In terms of pseudocode, I'm going to check is counted number index 2 is greater than counted number index plus 1 and the column is same 2. This way is going to check whether both values are greater or smaller than each other. If it is true, then it's going to swap. Otherwise, it's not going to swap and it's going to move to the next index position. So let's now look at the code for our specific question. Before you look at the bubble sort code, you have to look at this syntax that I am telling you, that every time you do a bubble sort, first you have to make a Boolean variable swap. Swap is going to keep a record of whether a swapping happened or not. So first you have to set it to true, then you have to apply a while loop, and inside the while loop you have to set it to false first because there's no swapping at first. Then you have to start from the first tilde per limit minus 1 boundary limit. Okay, then you have to compare. If counted number index 2 is less than counted number index plus 1 2, then you have to swap column 1. As I told you that you have to create a temporary variable for both the column 1 and column 2. In these temporary variables, you have to first store that number, then you have to swap it, like you have to move the second one to the first one, and then you have to place the second place the temporary variable back into the second place, just as we did. And we do the same for the second column as well. And once we've set it, we have to set it to true. Now the final step for this question was to output the chance for a number that would likely be appeared or not. So we have to loop it from 1 to 10 because we have 10 random numbers. And for the chance, we were given the formula in the question that we have to divide the frequency by 100,000. And how would we access the frequency? The array name, index, and second column. This one is row and this one is column. Then we have to output it simply that this integer and this is the variable counter number index 1. This one was the random number. And this is the chance for the random number, chance. Here we calculated the chance. And for an example, I would like, for example, this random number 2 was generated 150 times. Okay, so how would I calculate the chance? 150 divided by 100,000. Yeah, so it's just simple.